Going to talk about solving trig equations. So when you use the word equation, that means there better be, right here, sorry about that, there better be an equal sign in there. Okay, this is an equation. We're trying to find which angle would make this equation true. So 2 times the sine of some angle minus 1 would make it equal to 0. So think about this like algebra. Okay, so let's get as close to that variable as we can. So let's add 1 to both sides. You'll end up with 2 sine theta equals 1. Then divide by 2. And then you get sine theta equals 1/2. All right, so now we are not talking about, I'm going to write that over here. We are not talking about sine inverse of some ratio equals an angle. We are not talking about this, and sine inverses are restricted, right? So there is no sine inverse going on here. All right, so what we want to do is find every place, every single angle that makes this true, every single one. So to do that, we look at the unit circle. So I'm going to draw a unit circle here as best as I can. Okay. Oh, that worked out pretty well. Okay, so where are the sine ratios positive? Okay, so here's another little recap. The sine of an angle is equal to opposite over hypotenuse. Okay, which is the same thing. The opposites are always y's, and the hypotenuse is the radius. Okay, so the sines are like the y's. They are influenced. The radius is always positive, right? The radius is always positive. So where, in this case, we have a positive ratio here. So where are the y's positive? That would be quadrant 1 and quadrant 2. Okay, so draw yourself in a triangle in quadrant 1 and quadrant 2. And if you look at your special rights over here, which one of these angles would make a sine of 1/2? Okay, opposite over hypotenuse. That would be your 30-degree triangle right here. Opposite over hypotenuse is 1/2. So put in a 30-degree reference angle right here, 30, and here 30, right? Opposite over hypotenuse, opposite over hypotenuse. So in both of these quadrants, the sine of these angles would equal 1/2. So what are they? From 0 to here, and from 0 all the way around to here. Okay, so that would be at 30 degrees and also at 150 degrees. Okay, but there's one more piece to this. They didn't specify in this problem, but I want to show you the concept. Okay, if you're looking at just the unit circle going around one time, these are your two answers, 30 degrees and 150 degrees. However, if you recall, the unit circle is kind of like a radar. It keeps sweeping around. That radius keeps going around and around and around and around this unit circle, right? So what you have is you going around to here. Oops, this is working. The sine of this angle 30 is equal to 1/2. Keep going around. Yes, at 150. Guess what? It keeps sweeping around. Now it hits this again. What is that? 30 degrees plus another rotation, plus 360. Okay, then it keeps going around here. What was that? 150 plus another rotation for that around the circle. Okay, and it keeps going again and again and again and again. And guess what? It could also go backwards, right? You can go backwards and backwards and backwards. Okay, so your answer for this is every angle, it's 30 degrees plus every rotation or minus every rotation around. And you use K as your counter, okay? So K is just a variable which stands for the first rotation, the second rotation, the third rotation, right? 1 times 360, 2 times 360, 3 times 360, 4 times 360, or backwards 1 times 360, like that, all right? Or it's at 150 degrees plus or minus every forward or backwards rotation. The first, the second, the third, the fourth, the fifth, the sixth, the seventh, exactly. That's what that K stands for, okay? And this is your answer right here, okay? All right, let's try another one. Try it for the cosine. Same idea, okay? So I'll go over here. So if I say the cosine of theta equals a 1/2, all right? So with your special rights over here, which one of these special rights would give you a cosine of 1/2, okay? Adjacent over hypotenuse, so not 45, not the 30, but the 60. Adjacent to 60 over hypotenuse, okay? 1/2. So it's a 60-degree reference angle. So you're trying to find everywhere on the unit circle that this would be true. Okay, so draw yourself a circle. This one happens to go automatically. So now, where is the cosine always positive 1/2? That would be in quadrant 1. Everything's positive in quadrant 1, and also in quadrant 4. If you recall, the cosine of an angle is equal to adjacent over hypotenuse, or adjacent is always x, and over r is the hypotenuse. The radius is always positive, so since this is a positive ratio over here, we're looking where everywhere you have a positive x. Positive x's are in quadrant 1 and in quadrant 4. All right, so draw your triangles in there. Quadrant 1, quadrant 4. And what do you have? Adjacent is 1, hypotenuse is 2. Adjacent is 1, hypotenuse is 2. And we determined that that would be a 60-degree reference angle. All right, so just to clarify again, this is not cosine. Not sure why I did that. Cosine inverse of 1/2 equals some angle. Okay, it is not that. Cosine inverse is restricted. This is an equation. This is solving an equation. Okay, so they want to know every single place on the unit circle for all history where the cosine would equal 1/2. So where would that be? That would be from 0 to here, and from 0 all the way around. As you see, there's no restrictions. You can go anywhere you want to. Just go in the positive direction or in the negative direction, okay? So in the positive direction, you have 60 degrees, okay? Or all the way around from 0 to 300 degrees, okay? And not only that, but it is 60 degrees plus every rotation from here, plus one rotation, plus another rotation, right? Every rotation forward or every rotation going backwards, okay? So that's pretty messy looking. So let me write the answer. So your angle is 60 degrees plus every forward rotation, right? First, second, third, that K stands for 1 or 2 or 3 or 4, right? The first rotation, the second rotation, third rotation, fourth rotation, or backwards from 60. Backwards 1 rotation, backwards 2, backwards 3, 4, all rotations of all time, or 300 degrees plus or minus every forward or backward rotation. Okay, and that is your answer for that one there. Okay, so I'm going to end this recording now, and I'm going to do another second recording with some extra examples